That might be because you weren't able to, Jake, you were supposed to be number 14, but we gave you a different one, and that might be what's going on. I think I just need batteries for that. All right, so let's go through this. Now, we actually did pretty well. I mean, compared to, on this first couple anyway, compared to the other class, there were a few more that missed those, which, by the way, somebody had asked me, or a couple people asked me on this last quiz, the one we just took about the average, the class average, and what it was or whatever, and they just curious where they were. And it was kind of an interesting quiz. Now, it's not necessarily unusual for this to happen on that particular quiz because of the makeup of those story problems. If you weren't able to set them up, if you couldn't get started on them, then it was hard to get very many points. So it would seem like most people that could set it up and kind of get going maybe missed one little thing towards the end. And then if you were on the other side of that boat where you couldn't get any of the points, obviously there could be a big disparity in scores. And that's kind of what happened. If we look at the average on that quiz we took Friday, the average, the mean, was like 72%, which is low, lower than most of our quizzes. The median, what's the median?
The one middle.
That's the grade that actually where there's just as many scores above that score as there are scores below that score. Now, in most of our quizzes, the mean and the median are pretty close together, roughly the same. This particular quiz, the median was 85. So what's that mean? What they call the outliers in data, some really low scores pulled the mean down. So if somebody was going to ask me what's the average on this one, I would say 85, which is really better than most of our quizzes, and probably as good or better than we've done a lot of years when on that particular quiz. So I would say that was pretty good. When we talk about mean or average on this, we're talking about that 63% and so forth. I'm talking about an average on those particular cases because there isn't usually quite the spread in this one. All the scores are low on the midterm. I mean, if you go raw school, 60-some% or whatever. So we'll see. Why is it that hard? Somebody in the art class asked, why did they get so tough? Well, remember, it's a nationwide test, and they're really trying to identify, where, they want to make it a challenge to the very highest and the very best, of somebody that might be taking it, but yet they also realize that doesn't mean that means an A or the top score has to be, 90%, the top 90% or whatever. So I won't work through number one because we did really well on that one, but I'll just remind you that the point is for it to be continuous means that where one stops when x is 5, the other graph starts, and for it to be continuous, there can't be a gap there. So they have to have the same output. So you just put a 5 in for x to each of those, and then you set them equal to each other, and you get b equals -4. So the answer was C. Now, a comment that I would make about the packets and the midterm in general. The hardest or the most challenging probably of all of the parts is this part right here, the no calculator multiple choice. Because this is the part where they ask all the pre-calculus questions, where you've got to know your trig stuff. You've got to know what the natural log graph looks like. You've got to know all that stuff is pretty much lumped into here. Because the calculator parts, you can just use your calculator for that. And on the free response no calculator, they usually don't want you to get hung up in the algebra and that stuff. They want to see that you can work through the calculus stuff. Matter of fact, on one of the free response questions, some of you may have started working on those already, there's a problem, it's even a calculator problem. I think it's number 1. They give you f, the function f, and it's a quotient, and then they give you f prime right there. Well, the reason is they know that if you messed up the quotient rule and messed up f prime, that was going to throw off all the rest of the problem, and they didn't want you to have to worry about that. So they just gave it to you. Here's f prime. And then they go ahead and they ask you some questions. So if they're going to quiz you on your derivative rules, or they're going to quiz you on your pre-calculus stuff, how well do you know that stuff? It's going to be in this section right here. And actually, number 1 had that, because right here you get sine of 5 pi halves. You have to know that sine of 5 pi halves is 1. You have to be able to do a unit circle, or you have to be able to graph the sign graph. If you can't do that or don't know that value, you're probably not going to get that one. Okay, so as we're working through these packets, pay careful attention in the no calculator parts that you go through and you review those things. Okay, number 2 we didn't do too bad on as well. This is where you do the derivative. You set it equal to 0. Relative max is the same as local max. Okay? Now, there are several places in this particular problem, even though we did pretty well on it, I want to point out a couple things. The no calculator, or well, both the multiple choice sections, there's kind of a time pressure. On the actual AP test, you get 55 minutes to do the 28 questions. That's 2 minutes a question. Okay? So on our midterm, now it's not going to be quite as bad because the free response, the time pressure isn't nearly as much. And we're going to combine the multiple choice and the free response, so the time pressure won't be near as bad on the midterm. But when you're working under the gun in the time pressure on these multiple choice, it's nice if you can maybe find some little shortcuts and ways to save yourself a little bit of time. Now, a couple of things that come to mind on this problem, and they're not important. You don't have to do these. I'm just saying, if time is going to be a concern for you, this is something you might think about. So we would do the derivative, or let's see, that's y. So we'd do y prime would be 6x minus 3x squared. We're going to set it equal to 0. We're going to factor out an x. We get 6 minus 3x equals 0. So we get x equals 0 or x equals 2. Now, a couple of things that could help me go a little quicker on which one of those is a max. If I was working this out kind of our traditional way of finding local max or min, what would I do next? I would do a number line. I would do a y prime number line. I would put 0. I would put 2. I would pick some numbers here. I would come up here to my y prime line right here, be a good one. If I put a -1 in there, I get a negative. A -1 in there, I get a positive, so that'd be negative. Put a 1 in here, I get positive, positive. Put a 3 in here, I get a positive. 6 minus 9 would be negative. So there's my max right there at 2. And if I look at my options, that's the only one that has an x-coordinate of 2. So I don't even have to plug in. Where would I plug in to get the 4, by the way? I'd have to go back to the original to do that. Now, there have been several ways I could have shortened this. One way would have been knowing what this graph looks like. It's a cubic with a negative leading coefficient. If I know that, then I know that this cubic does this. Now, it also could have done this and there wouldn't have been any local max, but no local max is not one of my choices. So I know there's got to be at least one local max. And since I know it's a cubic, I know it can only have one local max, right? Because the most of these humps it can have is 2, and one of them's got to be local min. And since I know it's a negative leading coefficient, I know the minimum is going to come before the maximum. So as soon as I got down to here, I could have known that that's going to be my local max without having to go through and do the number line and so forth. Again, if you know that, if you see that, use it, fine. If not, the most important thing is not how fast you do it. The most important thing is you get it right. So if this is one that you say, hey, I know how to do this, then by all means, make sure you spend the time that you need to get it. Okay, because trust me, if you're under the time pressure, there very well may be some multiple choice ones you just skip. Now you should bubble them in. This is like the ACT, no penalty for guessing. Right? Was it SAT that you get penalized? SAT, you get penalized for guessing, right? The ACT, you don't. You should bubble everything in, and that's the same on this. Now, 2 years ago, they changed that. It used to be there was a penalty for guessing on the multiple choice. Not anymore. So you want to go ahead and you want to make sure you fill everything in. But, leave a blank until you're at the end, and then it's, if you run out of time, then fill it in. Okay, I want to talk about number 3 next, because we really did lousy on this one. 24% of you got number 3 right. A whole bunch of people, I think, put A. Does that sound right? A lot of people put A? Okay. Now, this is one that is similar to what we've just been learning, related rates. They talk about a line going through the origin,
Theta is this angle right here. It says as this rotates around the origin, what is the rate that the slope is changing? Well, you need to write an equation for the slope. Now, a big hint is all of the different choices. They all have trig in it. Almost all of them have trig in it. Okay? Now, it can't be A. Well, it could be, I suppose, but A is how fast theta is changing, not how fast the slope's changing. Now, if they're the same, then, of course, that could be it. Turns out it's not. Okay? What's an old algebra phrase for slope? Rise over run, right? So if you would take this picture, here's the rise, here's the run. What's another, using trig, what's another name here for rise over run? Tangent. The tangent of theta. So this slope is equal to the tangent of theta, and that's actually true. In any line that goes through the origin, the angle, the tangent of the angle is the slope of the line, because it's opposite over adjacent, which is rise over run. That's always true. And they want to know the rate that the slope is changing with respect to t. So they want to know m prime. So that's just the derivative. We do the derivative both sides with respect to t. So we get m prime. What's the derivative of tangent? Secant squared theta times theta prime. Don't forget, we're doing the derivative with respect to t. Theta prime. All right. Now, you look at your answers, and there it is. Right there. Secant squared is the same as 1 over cosine squared. And theta prime is the same as d theta dt. Okay, so the right answer was D. Okay? Now, that was a little more challenging one. As we work these, we should probably get a little better at it. But you've got to spend time with them. All right. Oops. Number 4. Again, we struggled with this one just a little bit as well. How many zeros does f prime have on this closed interval? Okay, so we have to be able to do a derivative. Again, this is what I'm trying to point out some of these things that were going to be useful to you as we go along. My goal here is by the time we get through about 3 of these packets, you've picked up quite a bit of different hints. You've practiced putting some of these together in ways you've never had to put them together before, and it's going to help us know all this stuff better, and then hopefully do better on the midterm. But how many zeros does f prime have? So we have to do the derivative of that. Well, what's the derivative of e to the u? Well, it's e to the u times u prime. Derivative of the inside. So the derivative here is e to the sine x times the derivative of the inside, which is cosine x. This is the kind of stuff I'm saying has to be on your paper. So you might take this time, right? You writing this down?
I'm watching you do it.
But you might want to write this down. I mean, I don't call that cheating. But you're right. You want to go back and do it on your own.
I want to watch you do it.
That's fine. You go back and do it on your own, that's even better. But make sure you do, because when we hand these in, you're going to hand these in at the midterm, and I'm going to go through and I'm going to be looking for completion, which is looking for your work. Okay, not just answers, but looking for your work. And then I'm going to pick random ones out and I'm going to grade them individually. And that's going to be like a quiz grade, the packet grade. Okay, so this is going to be an important grade. All right, so we get this, set equal to 0. Now, we're looking between 0 and 2 pi. So this, again, this question gets at several things. You know your derivative rules. It also now is going to check some of your trig knowledge and some algebra knowledge. Okay, 2 things multiplied equals 0. What has to happen? One of them's got to be 0. So either e to the sine x is 0 or cosine is 0. So if you're a unit circle kind of person, cosine is the x. Where's that 0? Pi halves, 3 pi halves. If you're more of a draw a quick cosine graph kind of person, where's cosine equals 0? Right there is pi halves, 3 pi halves. Okay? So, but there's 2 of them. We don't even care that it's pi halves and 3 pi halves. The question just says how many zeros does it have? All right, so there's 2 there. When does e to the sine x equal 0? You got to know about the e graph. E to a negative is 1 over something. E to 0 is 1. And e to a positive is going to have some value. It'll never equal 0. So that's never 0. So there are 2 choices. So B is the answer. Okay? But they were really quizzing your knowledge of several things. Okay, number 5. This would be one where you wouldn't necessarily have to have any work done. We talked about limits as x approaches infinity. We talked about L'Hopital's rule, but something we got to review here. If you get 0 over 0 or infinity over infinity in a limit problem, what's that mean? Keep going. That's indeterminate. Infinity over infinity is not 1. 0 over 0 is not 1. Infinity over infinity or 0 over 0 means you could do L'Hopital's rule or you could do some other technique, algebra. In this case, we talked about high powers dominate. Right? If x is going to infinity, then in this problem, this and this mean nothing. This term and this term mean nothing. As x gets really big, the only terms that matter are those right there. And to be honest, the 10 to the 8th and the 10 to the 9th don't matter. They're kind of distractors. They're thrown in there, but you don't even need to worry about it. The only thing that really matters is the fact you have x to the 5th on top and x to the 6th on the bottom, which means what? The bottom's getting bigger much faster because of the x to the 6th is going to overpower the x to the 5th. And if the bottom gets bigger faster, what happens to the fraction? It goes to 0. It gets smaller and smaller and smaller, goes to 0. So there would not be, you would not have to have work on that. If you got into L'Hopital's rule and tried to do derivatives, you would just have to do a bunch of them and it would be messy. That one, it's best to think high power dominant. Okay, we're spending a lot of time on these initial ones, but that's our first go at this. Let's go to number 10. Now, number 10, we did better than the other class, but not good enough. We had about 50% get this one right. And that's of the people that answered. That's not even counting the people that left it blank. They give you, what am I doing here? Okay, they give you a, listen up please now. They give you a velocity graph and they ask you about the speed. Now this would be a really good time to review this important concept. We haven't had to deal with it very much, but you're going to see it a lot in these packets. What's the connection between speed and velocity? One's direction, one's just a scalar, but I mean, what have we said about it? They're both rates. Speed is equal to, there you go, the absolute value of velocity. That is a great equation to remember right there. If you just take a velocity equation and put bars around it, you've got a speed equation. Okay, now, that's one thing. But we don't have an equation, we have a graph. Well, what happens when you take the absolute value of something? Everything turns positive. Well, you can do the same thing with a graph. Everything that's down here that's negative would turn positive. Here would be the speed equation in blue right here. Okay? That would be the speed graph. So now, you tell me, looking at that graph, which point has the greatest speed? Point D. Point D. Now, a lot of people put C, and I think you were thinking the slope. But that's the velocity graph, which is already speeds. The difference is some's positive, some's negative. You wouldn't be looking at the slope. That'd be acceleration. Okay? So C, actually, the velocity is 0, which means the speed would be 0. It can't be the greatest there. Okay? So it's D. That would be one we would want to have 100% getting that, because that's just too easy. And there's not much work to really show there. To be honest, you wouldn't have to draw this graph. You could just look at it and say, hey, velocity is negative, but that just means it's going left or going down. But it's going faster here than it is here because it's got a larger number. Okay, so you could just have looked at that one and gotten that answer there. Okay, I'm going to jump ahead because I do want to give you some work time again today. I'm going to jump to number 22. Number 22, we got 27% of you got that one right. And some of you left that one blank. All right, what does this mean that they're asking for? Second derivative. When you see that, it doesn't mean squared. It simply means y double prime. And dy dx is y prime. So they told us y prime was x squared, y squared, and they're asking us for y double prime. So therefore, they're saying, find the second derivative. Well, we already have the first derivative. Now this is with respect to x. So we just need to do the derivative of this. Now to do the derivative of this, we have to do what? We have to do a product rule. So we do the derivative of x squared is 2x. Why not do we tack on x prime? Because that's when we do it with respect to t. Here we're doing it with respect to x. The derivative of x with respect to x, that'd be dx dx. That's just one. We don't tack on an x prime. We leave the y squared alone. Plus, we leave the x squared alone, and the derivative of y squared is 2y y prime. Now, we did not do very many y double primes when we were doing implicit differentiation. I'm not sure we did any. Okay? You notice when you do y double prime, you end up with a y prime in it. We don't want that. Look at our answers. None of them have a y prime in it. What do? We know what y prime is. We wouldn't have gotten to y double prime if we didn't already know y prime. So you always have a y prime that you can then substitute in. So right there, we're going to stick that in. So for y double prime, we get 2xy squared plus, I'm going to bring the 2 in front. This would be x squared y, and then in place of y prime, I'm going to put x squared y squared. So we get 2xy squared, and now put this all together, I'd have a 2, I'd have an x to the 4th, I have a y cubed, which I think is e right there. Okay? So you really, it really runs the gamut. It's all the stuff we've been doing. Now, there are a few things that won't be in here. Parametrics are not on the AP exam. Okay, now they're in the BC. There's still things you have to do in calculus, and there'll be things you run into in college, and so we'll still do some of those things, even though they're not on the AP test. Okay, but you won't see parametrics in here. Most everything else we've done, though, is in here. Okay, 22 is what I wanted to do. Let's take a look at, is 25 one we need to look at? Oh yeah, there was something, this was interesting. I wanted to talk about 25 here. For which, this gets, yes?
Can we do 24 after this?
Yeah, I think so. 25, for which pair of functions f and g below will the limit as x goes to infinity of f of x over g of x equals 0? Now this goes back to what we were talking about on that earlier limit problem. What has to happen for the limit, as x gets really big, for the limit of a fraction to go to 0? The bottom just has to get bigger faster. If you look at these functions, they all get bigger. Every one of these functions get bigger. But what we're looking for is a g that gets bigger faster. Well, this is no calculator. So this is where I've been telling you, you have to know what natural log looks like. You got to know what e to the x looks like. You got to know these things. This is a classic example of that. Okay? Now, starting from the bottom, 3 to the x is going to get bigger faster than 2 to the x. They both get big really fast, but this one will not get bigger faster. Natural log grows very slowly. Natural log does this. So it does not get big very fast at all. E to the x gets big really fast. Compared to natural log, definitely. So that's got to be the one. Just to make sure, we'll go through these. This one gets big really slow. X squared gets big pretty fast, but not nearly as fast as e to the x. So it is choice C. So again, there would be one, really probably no work to show, but you just have to know the relative rate of growth of these different functions. Okay, you said 24. Is that on that same page, or is that? Oh, okay. They asked for h prime of 3. Now, before you can find h prime of 3, you need to know h prime of x. This is a product rule. H is f times g. So h prime of x is f prime times g plus f times g prime. Right? So that means you need to do h prime of 3, you need f prime of 3, you need g of 3, plus f of 3 and g prime of 3. Now since they're all lines, we should be able to get those slopes. So f of 3, or f prime of 3, where's the f graph? This one? So at 3, what slope does the f graph have? Yeah, looks like it's 1, 2, 3 over and 1 down. That'd be negative 1/3. So you get the idea? And g of 3 would just be the output right here, which is 3. F of 3 would be that output, which is 1. And g prime of 3 would be this slope, which looks like it's over 1, up 1, over 1, up 1, so that's a slope of 1. So it looks like we get negative 1 plus 1.
For some reason I kept putting the f prime as negative 3 instead of negative 1/3.
Oh,
I was just doing that stuff.
You're gonna run over eyes or something.
So I kept getting 8.
Now-
Like those numbers.
that's interesting that they didn't, because a lot of times they'll take your common mistakes people might make, and that'll be one of the choices. So it must have been an uncommon mistake. I'm not sure why that wouldn't have been one of the choices in there. All right, I want to do one more, and that is number 35. Now, when we have some work time, if you've got some that you want to ask me about, we can do that. But I want to take a look at number 35. Now we're into the calculator one, okay? Now, it says that you can use a calculator, but I'll be honest, some of the time, again, think about time limit. Now, the calculator ones, they give you a little more time. I think on the AP tests, there's 17 questions, 50 minutes. So that's about a 3-minute per question, average. They figure that typing stuff into the calculator is going to take a little longer, so forth. But not all of them need a calculator. Matter of fact, the one right before that, 34, I don't think you needed a calculator at all for that. I mean, it was pretty simple stuff as far as the calculations go. Okay, there was several of them in there in the calculator section that really you probably could have done faster without the calculator. So just because it's a calculator section, don't think you have to use the calculator. All right, on this one they tell us that we've got a road that's in the shape of a parabola until it gets to B, and then it changes into a line. Now it says, this is an important statement right here at the end. And one of the things we're going to talk about here at the end of chapter 4 is continuity and differentiability. Continuity means, no breaks, no gaps. Differentiability means that the derivative exists everywhere. Well, remember, one of the places where the derivative doesn't exist is a sharp point. So for this to have the derivative exist, or to be smooth, not have a sharp point, not only do these y values have to meet at the same place, but they have to meet with the same slope. In other words, the slope that the one graph is coming in has to be the same as the second slope going out, so it stays smooth. So right there they say r prime is continuous. Well, basically what they're saying is r is differentiable, that the slope is the same for both of those. And that's the key to this question. Because the first part of this question is just like question 1 was. They tell you that B is 1,000 feet horizontally from A and 100 feet higher. So this point here is 100 at B. Well, what that means is right here on R, when we put 1,000 in for X, this is just like question 1 was. Since they're continuous, they have to have the same output. Now in this case, we know the output has to be 100. So we can put a 1,000 in for X here, so 1,000 squared times A has to equal 100. And we also know if we put 1,000 in here that 1,000B plus C has to equal 100. Okay? Because that's where the parabola of the line when X is 1,000. Well, this one has B and C in it, so I'm going to ignore that for a minute. But this one I could find A real quick. You could take 100 divided by 1,000 squared. Now you could use your calculator for this. But it essentially is going to come up with 1 over 10,000 is what that's going to be. A is going to be 1 over 10,000. Okay? Now, I've jumped ahead of myself a little bit here. The question says, what's the value of B? I may need that. I'm definitely going to need that. But I can find what A is. But that's doing exactly what we did in number 1. All right, but now the secret is this extra thing here. Not only does R have to have the same value when X is 1,000, but R prime has to have the same value when X is 1,000. So what we have to do is write R prime. Well, what's the derivative of AX squared? 2AX. What's the derivative of BX plus C? B. Now we don't know what that slope is right there at point B, but we do know that the slope, that both of these have to be equal. That the slope is R prime, and those have to be the same. So we know when X is 1,000, I'll put 1,000 in for X, that those have to be equal. Okay, at this point, which is when x is 1,000, these two have to be equal. Well, now since we know what a is, so what we have here is 2,000 times 1 over 10,000. And again, you have a calculator for this to help. But those 3 zeros will cancel 3 of those zeros. We get 2 over 10, which is 0.2. So there's your answer right there. But what they were really getting there is, do you understand what continuous means? Do you understand what differentiable means? Do you understand that for that to be smooth right there and not have a sharp point, the slope of the first graph as it comes in has to be the same as the slope of the second graph. The derivatives have to be equal. Okay? And so there's the calculation. That's a little longer one. That's more than 2 minutes or 3 minutes, whatever. But you know, some are going to be easy, like we talked about. Some you should be able to just hopefully just see pretty quickly. Some you're going to spend more time. Okay. So you can have some work time for whatever you didn't get, or you can check. The answers are in this thing, but our assignment for tomorrow, and I'm going to give you the last half hour here, is to work on the rest of the packet, the free response. Okay, question 1, you do all the parts, and then question 2, then there's some of them where you only do a few of the parts. Okay, whatever the circle parts are, the rest of the packet. Okay, now, this is one of the last times, well, there'll be another day or so where our only assignment is stuff in the packet, but there will be a lot of days where we have kind of a homework assignment out of the book, and then you're also supposed to be working on some of the packets. Okay, and so it's going to be kind of, you know, between now and the midterm, between now and the next 2 weeks, you know, probably doing a handful of the packet problems as a part of each night's homework if you want to get, you know, done with them in a time advance. Okay, go ahead and work the rest of the time. And I will help you as you need it.